Welcome to Putting Together the Pieces, Program 2. This program demonstrates adding two very important tools that programmers use regularly, lists and decisions, into a program. Let's get started. The first step is to analyze and define the problem, which has already been done for us. Create a program that prompts the user to enter a student's name and their midterm and final exam scores. The program should compute their semester average based on the two exam scores and then determine their letter grade. The program reports as output the name, midterm, final, semester average, and letter grade. We will use our input, process, output strategy to formulate a workable design plan. Starting by identifying the outputs, we see that the program should display the student name, midterm score, final score, their semester average, and the letter grade assigned based on the semester average. We add these to our IPO chart. Next, we identify the inputs we get from the user of the program. The user is to enter a student's name and their midterm and final exam scores. Now we can subtract the inputs provided from the outputs we need to report. This will help us determine what processing needs to be done. Since this requires two steps, let's use a process called stepwise refinement to individually consider these two outputs we need to produce. Do we have the information we need to compute the semester average? Yes, we will add the midterm exam score to the final exam score and then divide by 2 to get the semester average. Based on the average, we can assign the letter grade A through F based on 10-point ranges. An average below 60 would be failing. An average greater than or equal to 60 but less than 70 would be a D. An average greater than or equal to 70 but less than 80 would be a C. And an average greater than or equal to 90 would be an A. Here is a flowchart that matches the logic. We will use this to code our solution. The coded solution is based on the algorithm we created by decomposing our IPO chart and then flowcharting the decision logic. Here is a sample solution. Notice the use of comments, also known as documentation. When coding problem solutions, you should always include a description of the problem, as well as identifying yourself as the programmer and the date the program was developed, as comments in the top of your program, to identify the inputs, the processing, and the outputs. Since all of the data in this program refers to one student, it makes sense to use a list data structure. The name we are using is student list, and it will consist of the student's name, midterm score, final score, the computed semester average, and the letter grade that is determined and assigned based on that semester average. Recall that a list is an ordered collection of related items. All of these relate to one student. When coding a list, remember to use brackets and that the indexes start at 0. Here is the initialization of the information for student list. We have a default for the name, 0 for the midterm and final exam scores, as well as the semester average, and then an empty string for the letter grade. The input portion of the code prompts the user for the name, midterm score, and final exam score. The end equal empty quotes keeps print from advancing to the next line. This will allow the user to enter their information right next to the prompt. Remember that all input comes into the Python program as string data, streams of characters. Since the midterm and final exam scores are numeric, the input typed in by the user is sent into the float function to transform it into a decimal type. Next, we store their values in our student list using the appropriate index to assign them. 0 for the first item, which is the student name, 1 for the second item, which is the midterm score, 2 for the third item, which is the final exam score. Here is our coded process part, which corresponds to the business logic. We refined this into 2 subparts. First, we calculate the semester average and assign it to item 4, student list sub 3. The next part, using the average to determine the letter grade and assign it to a student list sub 4. The second part is the decision logic based on the flowchart shown. We check, is the semester average less than 60? If so, then we need to assign a letter grade of F. But if not, let's see if it's less than 70. If it is less than 70, it had to have been greater than 60, and we assign the letter grade of D. But if it's not less than 70, then we check, is it less than 80? If that is true, we assign the letter grade of C. But if it was not less than 80, we check, well, was it less than 90? If that is true, we assign the letter grade of B. Finally, if it wasn't less than 90, then we assign a letter grade of A. Notice that after we assign the letter grade, we're finished processing. So after each one of these assignments of the letter grade, we just proceed to the end of the if-elif. Remember that indentation is important. Recall that it identifies the blocks of instructions that belong together. We organize the lines of code into logically related sets of instructions called blocks. We must start our block of code with a colon and indent to the same column every related instruction. Once we have completed all the processing, we can display the output. Notice the simplicity of using the list. We have a print statement for headings, name, midterm, final, average, and grade, and then a simple print student list statement that will display all of the items in order that are stored in the student list. Here is what sample output looks like. If we enter the name Amanda with a midterm grade of 89, a final grade of 95, The output tells us that Amanda had a 92 average and a grade of A. The sample code is posted, and I encourage you to test it out by running it a few times. As a programming exercise, it would be good practice to recode this process for determining the letter grade, starting with identifying the A grades first. Here is a start. You can use the sample code provided to finish it. Happy coding!